Good evening, dreamers. Welcome to DreamtimeScience, the place where wonder slows to a whisper and curious minds drift into sleep. If you've arrived here, you're probably searching for something equal parts soothing and slightly nerdy to carry you toward tomorrow's sunrise. You're in the right place. As twilight embraces the world in its tranquil hold, we prepare to embark on a journey into the silent ballet of the cosmos, the quiet dance of dark matter. This elusive and enchanting performer, invisible to our eyes, yet integral to the celestial waltz, beckons us to explore its mysteries. So, settle down, dear dreamers, as we glide very slowly, very gently into the cosmic darkness, keeping a safe, pillow-soft distance, yet close enough to touch the wonder of our universe. Before we begin, may I ask a tiny favor? If this kind of midnight science story helps you doze, a quiet like or subscribe lets this sleepy corner of the internet keep glowing. And because I love to see how far the starlight travels, where are you listening from and what time is it there? Slip your answer into the comments below. I read them like bedtime postcards. Now take a moment, adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. Ready? Then close your eyes and let's wander together. As the night deepens and the world grows still, imagine yourself stepping beyond the boundaries of the familiar, drifting slowly into a vast expanse where time ripples like gentle waves on a silent ocean. Picture now an ancient, endless library where the shelves stretch away into depths unseen, each volume a story of the cosmos written in the language of light and shadow. Here, in this sacred quiet, we begin our gentle exploration of the universe's grand composition, a tale woven with threads both seen and unseen, illuminated and obscure. Long before our eyes were open to the stars, before our instruments whispered back signals from distant corners of existence, the universe was already vast and mysterious. It is a realm made not just of the matter that forms the tangible world around us, the stones beneath our feet, the air we breathe, the fire that burns softly in a candle flame, but also of something far more elusive, something that eludes the gentle touch of our senses. This is the story of the cosmos's two intertwined fabrics, the familiar, the visible, and the shadowy and invisible. The visible, comprising all that shines or glows or reflects, represents only a mere fraction of what the universe truly holds. It is what we call ordinary matter. Let your mind drift slowly to the night sky, where countless stars flicker serenely. These stars, like the sun that warms our world and the planets that revolve around it, are made of atoms, protons, neutrons, and electrons dancing in quiet harmony for billions of years. This ordinary matter, though all around us and deeply known, accounts for only a whisper of the universe's entirety. Imagine it as the delicate embroidery on a vast cosmic tapestry, intricate and beautiful, yet representing just a small pattern within an immense weave. Beyond this shimmering embroidery lies the more silent, denser fabric, dark matter. Its name alone suggests mystery, yet it is neither dark nor matter in the sense we typically understand. It neither shines nor absorbs light, remaining hidden from our most sensitive instruments that depend on electromagnetic signals. This unseen companion of the cosmos exerts its influence subtly and profoundly, shaping the very architecture of galaxies, guiding their formation, and holding them in gentle gravitational embrace. If the glowing stars and galaxies are the visible islands in the cosmic ocean, dark matter is the vast, invisible water in which they float, unseen yet unyielding. To explore this further, envision yourself floating gently through a calm night sky, moving beyond the Milky Way, passing through the silent spaces between stars, between galaxies, until the universe stretches vast and unbroken. Here you notice something remarkable. The galaxies, swirling in graceful spirals or delicate ellipticals, move as though invisible hands guide them, tug gently at their edges, holding them together in ways that simple visible matter alone cannot explain. Astronomers and physicists, those patient seekers of cosmic truth, first sensed the presence of this unseen mass through their careful observations and measurements. As they studied the rotation of galaxies, much like watching dancers on a stage, they noticed something puzzling. The stars' speed as they circled their galactic centers did not slow down as expected with distance. According to the gravity created by visible matter alone, those distant stars should move more slowly, yet they did not. Instead, they raced along with an elegant, steady pace, as if drawn by some invisible cloak wrapped tightly around the galaxy's outskirts. This cloak is the dark matter halo, an unseen, vast and mysterious presence. Consider the calm persistence of this dark matter. It is silent, patient, and ancient. Its presence was first theorized in the 1930s, but confirmed subtly over decades with increasing precision, like listening to a faint whisper carried on a night breeze. It neither glows nor casts shadows, yet it shapes the universe on the grandest scales. It sculpts the cosmic web of galaxy clusters, stretching across unimaginable distances, marking the large-scale structure of the cosmos. Dark matter forms the scaffolding upon which the luminous material, the stars and galaxies, assembles. Slip now into a quieter reflection, imagining the earliest moments after the birth of the universe itself, almost 13.8 billion years ago. In that infant universe, the dense plasma of particles and radiation slowly cooled and thinned, allowing the first structures to arise. Ordinary matter clumped together under gravity's gentle pull, but it was dark matter that led the way, collapsing earlier and faster, forming the dark halos that would cradle the first galaxies, like the roots nourishing a vast tree yet to bloom. Picture the universe as a vast ocean of mist, where droplets coalesce into patterns, giving rise to shapes and forms. Dark matter is the mist upon which the droplets of visible matter settle and grow, merging into stars, then galaxies, then the grand galactic clusters we can observe from Earth. Without it, the universe would look very different, less structured, emptier, perhaps unable to form the dazzling variety of cosmic forms we cherish. Reflect slowly on what dark matter might truly be. It is not made of the familiar atoms or molecules that build our world. Instead, it seems to consist of particles yet unseen, elusive entities that do not interact with light or ordinary matter in the usual ways, except through gravity. Modern physics offers a range of possibilities, like gentle shadows cast by unknown fields or particles. Scientists have named candidates such as WIMPs, weakly interacting massive particles, or axions, ghostly particles too subtle for our present instruments. Yet despite decades of searching in deep underground laboratories, in particle accelerators, and in the cold silence of space, dark matter has not yet revealed its final secret. This very elusiveness invites a deep calm, a quiet acceptance of mystery. It is enough, for now, to acknowledge its presence, to appreciate its role in the cosmic story, and to let our minds quietly entertain its invisible shape. Imagine dark matter as a dark, gentle fog stretching through the cosmos, softening the edges of brightness, connecting everything with a subtle gravity. Though we cannot see it, it is a vital part of the cosmic dance, an unseen partner moving slowly but steadily in the shadows. Now, drifting further in your mind, picture the cosmic microwave background, a faint and ancient glow that fills the universe. This is an echo from the earliest time, a faint afterglow of the Big Bang itself, imprinted with whispers about the universe's infancy. Careful study of this faint light has revealed patterns that provide essential clues about the composition of the cosmos. It tells us that ordinary matter is but a small fraction, less than 5%, while dark matter makes up about 27% of the total universe's energy content. The remaining 70% belongs to another mysterious entity, dark energy, which we will gently explore in later parts of this journey. For now, the comforting embrace of dark matter guides our thoughts. Imagine a delicate scale on which the universe balances. A fraction of this scale is bright, warm, glowing matter, the stuff of stars and planets, our homes and bodies. Yet the greater weight on the scale comes from something unseen, a silent guardian of structure and shape, invisible yet immense, ever-present but eternally shy. Dark matter anchors the universe's vast architecture, preventing galaxies from flying apart, fostering clusters that defy entropy, and crafting the cosmic web that links galaxies in vast filaments. Reflect now on how this dark matter interacts with the ordinary matter we know. They do not mingle openly. The interaction is subtle and rare, limited mainly to gravity's gentle tug. You might imagine it as two dancers on a moonlit stage, one luminous, visible in the spotlight, the other cloaked in shadow, felt rather than seen, their movements entwined through silent, invisible bonds. In this grand cosmic ballet, stars, planets, and galaxies are but luminous notes, their glow shaped and framed by the dark matter's quiet rhythm. The dark matter surrounds each galaxy in a halo, like a hidden veil, drifting beyond the reach of telescopic light. This veil determines how galaxies grow and spin, how they cluster and drift through the vast darkness. It is as if the universe wears a hidden garment, soft and expansive, upon which all visible things rest. Slowly imagine yourself traveling alongside a distant galaxy, far beyond the Milky Way's familiar arms. Though it twinkles with millions of stars, it moves in a way shaped and stabilized by this invisible presence. As you drift around it, you sense the firm embrace of dark matter's gravity, steady and unyielding, a force quiet but profound, keeping stars from wandering too far, keeping hopes of cosmic structure alive. Contemplate this. Dark matter does not exist in isolation, but interacts with ordinary matter through the vast fabric of space-time itself. This fabric, flexible and responsive under Einstein's subtle equations, bends and curves under mass and energy's influence. Dark matter's gravity shapes the contours of this pliant fabric, guiding the flow of matter and light across the cosmos, creating cosmic lenses where light is bent gently around massive clusters. These gravitational lenses reveal dark matter's hidden presence, allowing us to map its shape with exquisite precision through the distortion of distant galaxies' light. Allow yourself a moment to rest in this knowledge, as if floating above all understanding, watching the universe's tapestry gently sway. The shadows and light intertwine, the visible and the invisible dance together in a timeless embrace. This cosmic interplay is the quiet foundation upon which all existence rests, the seen stars, the tranquil planets, and the vast darkness that holds them all in delicate balance. And so, as our quiet journey through the night's infinite library continues, we find the universe not as an empty void, but as a harmonic chorus sung by both light and shadow, matter known and unknown. And dark matter is a gentle mystery, a calm and steady presence, invisible yet indispensable. It shapes the form and destiny of galaxies, enveloping them in halos, weaving the cosmic web, and anchoring the universe's grand design. Rest with this thought as you drift further into sleep's embrace, that the cosmos is full of hidden truths, silent companions, and gentle mysteries waiting to be revealed bit by bit. Tonight, let the unseen fabric of dark matter guide your dreams, whispering softly of the vastness beyond, and the quiet dance that holds the universe together. As your breath slows and your body relaxes, carry with you the gentle image of countless galaxies serenely spinning in the calm silence of space, cradled by an unseen hand. Like a quiet guardian that never sleeps, dark matter watches over the cosmos, an eternal shadow that nurtures the light. And in this peaceful knowledge you too may find rest, wrapped in the calm and endless night of the universe. Sleep now, gentle traveller of the stars, with the promise that tomorrow we will explore further, deeper into the cosmic mystery, unraveling the secrets of invisible matter and the energy that fills the void between the stars. Until then, rest within the quiet fabric of the universe itself, calm and cradled by the dark. As we settle again into the quiet stillness that follows our previous gentle voyage through the vast realm of cosmology, let us now begin a new chapter of our whispered journey, an exploration not of stars or ordinary matter, but of something far subtler, far more elusive, the dark matter. If you recall, in our last voyage, we touched upon the evidence that suggests this invisible substance weaves through the tapestry of the universe, shaping galaxies and bending the light of distant stars, yet it remains unseen, untouched by any ordinary senses. Tonight we'll unwind slowly the delicate threads scientists follow to find hints of this mysterious presence, the traces and shadows it leaves behind in the cosmic night. Imagine, if you will, walking through a vast and ancient forest at twilight. The trees are tall and silent, their forms stretching upward in graceful arcs. The air is thick with a quiet stillness, filled only with the soft rustling of leaves and the distant call of hidden creatures. In this moment, your eyes cannot see the life beneath the soil, the roots which tangle and anchor the trees, supporting them, nourishing them, but invisibly. In many ways, the work of a scientist hunting dark matter feels like walking in this forest, not looking for the branches and leaves, but sensing the hidden roots and shadows beneath the earth, searching for what does not rise into the light. Our world of science is filled with the steady rhythm of careful observation, repetition, and deduction. Unlike an artist sketching freely on an open canvas, scientists must listen patiently to the subtle echoes of the universe, piecing together clues that the cosmos whispers in silence. Dark matter makes no light, no sound, no warm embrace of particles that dance in the sunbeams. It is a silent partner in the cosmic dance, and to detect its presence, scientists must rely on the softest traces, the hints it leaves on what we can observe. One of the earliest ways scientists began to suspect that something more existed beyond the familiar was by watching the gentle spin of galaxies. They noticed that stars at the edges of these grand spirals weren't simply drifting away or slowing down as expected from the gravity of the visible matter alone. Instead, they swirled and spun with a silent strength, as though hidden arms of gravity reached out to hold them close. This curiosity grew into an understanding that something unseen, dark matter was exerting a gravitational pull, holding the galaxies in their sweeping curves. But gravity is only a hint, a subtle force that travels through space, invisible yet undeniable. To catch more delicate whispers, scientists devised careful instruments and experiments, each designed like an ancient scribe's ink-stained quill, recording tiny fluctuations in the grand cosmic manuscript. One of these methods involves peering deeply into the night sky through the gentle prism of gravitational lensing. Imagine the universe as a giant celestial mansion, its walls shaped not only from stars and gas, but also from dark matter. Light from distant galaxies travels through this mansion, passing near these hidden walls. As it does, the path of light bends ever so slightly, much like a gentle ripple upon a still lake disturbed by an unseen stone dropped beneath its surface. The result is a subtle shifting and warping of background images, a bending of space itself, revealing a curved landscape crafted by invisible matter. Scientists, placing their telescopes to this sky, watch carefully for this warp, the soft distortion in the shape of faraway galaxies, curled gently and faintly as if through a mist. These tiny tweaks in the cosmic light create patterns, almost like a quiet fingerprint, a signature left behind by dark matter. The pursuit requires patience and immortal focus. Amidst countless light beams, they seek the delicate twist, the gentle curve, the barely perceptible bending that betrays the presence of dark matter's invisible hand. Yet, even as this lensing reveals the silhouette of dark matter, the question remains: how can we sense this hidden substance's own particles? For dark matter, if it exists as collections of particles, must interact rarely, if ever, with ordinary matter. But the universe's grand clock invites us to listen ever more closely. One path scientists travel follows the footsteps of particles streaming through space, perhaps colliding with atoms within ultra-sensitive detectors deep beneath the Earth's surface. Picture these detectors as great quiet halls, buried in the shadow depths of ancient mines or isolated laboratories far from the hum of daily life, cloistered sanctuaries where even the faintest whispers might be heard. These chambers are shielded from cosmic rays and ambient noise, designed to listen only to the faintest hint of a dark matter particle's subtle touch. Inside these detectors, time slows down as researchers wait for a possible event. A lone particle brushing past an atomic nucleus, imparting a minute tremble, a wisp of energy here, a fleeting flicker of light there. The instruments are so refined that even a single collision might be recorded as a tiny burst of heat or an almost imperceptible flash, clues that something unseen has passed through their crystal, noble gas, or silicon core. The patience required here is immense. For months or years, These experiments stand vigil, collecting data as a night watchman listens in the silent dark. Occasionally, a faint telluric signal might emerge, raising whispers of discovery, but often these hints dissolve upon closer scrutiny into background noise. This delicate dance of signal and noise, of hope and caution, is the hallmark of dark matter research. But the story does not end beneath the Earth's surface. High above, in the vast quiet of space, instruments on satellites and in observatories scan the skies not for light itself, but for evidence of dark matter's possible decay or annihilation. Imagine a pair of dark matter particles in the quiet vastness of a galaxy's halo, gently colliding or decaying, releasing photons in a silent cosmic firework too faint to illuminate the night, but picked up by specialized detectors sensitive to gamma rays or exotic particles. Scientists scan these gamma rays, those most energetic of light, like listeners tuning in to the faintest cosmic radio waves, hoping to distinguish a pattern amid the celestial symphony. The galaxy's center, dense and mysterious, is often watched closely, a place where the density of dark matter might increase the odds of these rare and subtle dances of particles. Imagine the patience and precision required to recognize these patterns amidst the background chorus of astrophysical phenomena, the glow of pulsars, the roar of supernova remnants, the frenzied activity of cosmic rays. Each source can create signals that mimic or obscure the delicate footprints of dark matter interactions, challenging scientists to peel back layer after layer of cosmic noise. From the depths of underground laboratories to the heights of space-based observatories, scientists weave a tapestry of techniques, a mosaic of efforts, each seeking a different thread of evidence. This network of experiments forms an intricate balance, a silent conversation spanning scales and senses, aiming to catch the faint whisper of dark matter's true nature. Alongside these direct detections, another path unfolds in the colossal accelerators humanity has crafted, machines that propel ordinary particles to unimaginable speeds and energies. The Large Hadron Collider, hidden beneath the countryside like a subterranean river of light, explores the fundamental rules of particle physics by colliding high-energy protons and peering into the shattered fragments. Here, scientists hope to create, or at least glimpse, particles of dark matter directly. Particles that, if produced, would disappear unseen, leaving behind an imbalance, a missing energy, like a silent absence in the intricate dance of known particles. Imagine these collisions as great cosmic dances choreographed in a vast underground ballroom, where particles emerge, spin, and vanish in a fraction of a heartbeat. The detectors surrounding the collision points are intricate mosaics of technology designed to spot each flicker of light, every traced path of charged particles. Still, the dark matter particles by their very nature, evade direct capture, slipping through undetected as shadows at the edge of a flame. The challenge is to infer their presence by the faintest gap they leave, the quiet hollow where energy and momentum are lost, a delicate fingerprint inscribed in absence. Science marches forward in small steps, each mission, each experiment, a gentle probe into the unknown. Yet we must remember, in this quiet pursuit, science is more than the instruments and experiments. It is also the rhythm of imagination and reasoning, of theory weaving frameworks that guide where to look and how to listen. Physicists have woven theories of weakly interacting massive particles or WIMPs, possibilities of ultralight axions, or even strange sterile neutrinos, each a candidate form that dark matter might take, but all requiring new windows to peer through. As you drift further into the soft embrace of the night, picture the endless, silent universe stretching in all directions, the grand cosmic ocean beyond even waking dreams. Somewhere within this vastness, beyond the glittering stars and glowing gas clouds, this silent matter flows gently, imperceptible yet essential, holding the cosmic web together. Imagine the dedication of scientists quietly waiting in their laboratories, peering through lenses and detectors, listening for the faintest ripple across space-time. Each night they look for a ripple in the fabric, a disturbance in the waves of existence, a gentle tug on the veil between the known and unknown. The story of detecting dark matter is a story of patience and subtlety, of listening intently to what is not said, watching the shadows at the edge of light, feeling the silent rhythms beneath the noisy symphony of the stars. It is a progression of gentle footsteps in an endless forest, feeling the secret shapes of roots that weave unseen beneath the ground. In the moments before sleep fully takes you, allow your mind to float slowly among these patient shadows and whispers. Hear the quiet rustling of discovery moving slowly through the cosmos, an ancient echo of the universe's secrets reaching toward dawn. Feel the gentle pull of hidden gravity curling softly around your thoughts, anchoring you in a vast, calm expanse where science and wonder become one. Let your thoughts drift as softly as particles, passing silently through a detector deep beneath the Earth's surface. Imagine the light bending quietly through curved space, the delicate alteration of distant galaxies' shapes in invisible hands. Sense the merging of particle and wave, the interplay of energy and darkness, as the universe continues its quiet conversation with itself. And as your breath grows slower, deeper, more even, know that the quest to uncover the dark matter weaves on silently beyond our gaze, a dream whispered across the night sky, waiting patiently to be found amid the infinite depths. Here in the hush of night, as shadows fold softly into sleep, let the mystery cradle you gently, until the dawn of new understanding stirs like the softest breeze among the silent trees. You have now floated through the delicate methods by which scientists pursue that which remains hidden, from the bending of light across great cosmic distances, deep into the earth's tranquil sanctuaries, waiting for whispers of particles, to the powerful accelerators spinning vast collisions of known matter, exploring new realms. With each breath you take, you become part of the patient stillness that listens to the silent universe, joining in the eternal quest for dark matter's secret song. As your eyelids grow heavy, picture these endless paths unfolding forever beneath the calm cosmic sky. And let yourself drift gently toward the realm of dreams, where mysteries await their quiet unraveling, where the universe speaks softly of all that we have yet to know. Rest now, embraced by the silence that surrounds all things unseen. The quest continues, endless as the night, patient as the stars, and as gentle as the passage from wakefulness to sleep. As we gently settle into this third part of our quiet exploration, let us carry forward the delicate threads we began weaving in the earlier chapters. You might recall the soft whispers of the universe's unseen hand, the mysterious substance known as dark matter, which gently sculpts the heavens with invisible fingers. Tonight, like a slow river meandering through ancient lands, we follow the subtle currents of gravity, the quiet architect behind the vast tapestries of galaxies slowly unfolding across the silent night sky. Imagine, if you will, the early universe, a vast ocean painted in hues of deep indigo and velvet black, punctuated by faint flickers of ancient light. It is a place where matter and energy dance in delicate balance, an elegant cosmic ballet. But lurking beyond the visible players is dark matter, an ethereal presence, unseen yet profoundly felt. This unseen mass drifts silently through the fabric of space and time, like an invisible silk thread woven intricately into the universe's grand tapestry. In this darkness, gravity reigns as the gentle guide, an ancient force shaping the very contours of existence. Dark matter, more abundant than the ordinary matter we can see, acts like a scaffold, a quiet framework around which galaxies slowly grow and take form. Picture it as an immense web, vast, delicate, and fragile, stretching across the cosmos, an invisible lattice supporting the luminous jewels we call galaxies. Long before stars sparkled their first fires, dark matter gathered together, drawn by the soft pull of gravity. Small clumps merged gently, like snowflakes drifting and landing softly in a vast, silent forest. These clumps, or halos, became cradles of creation, where gas and dust could collect, cooled by the unhurried passage of time. Around these dark matter halos, clouds of ordinary matter, a mix of hydrogen and helium, began their slow collapse, drawn towards the unseen gravity wells. This process is exquisitely quiet and slow, played out over hundreds of millions of years, a cosmic lullaby sung in the language of gravity and time. It is as if dark matter lays down roots deep beneath the surface, holding firm the ground upon which galaxies stretch their arms toward the light. You can imagine these halos as invisible gardens, fertile places where the seeds of galaxies are sown and nurtured. As the gas coils ever closer under gravity's gentle command, it becomes denser, spinning softly into disks that will one day birth radiant stars. The dance is slow, hypnotic, a tender exchange between the unseen and the seen. Dark matter, though it does not glow or shine, dictates the rhythms of this dance, guiding matter into graceful spirals and delicate clusters. In the quiet vastness, each halo varies in size and strength. Some are colossal, massive centers pulling in countless clouds of gas and dust, destined to grow into majestic galaxies with billions of stars. Others are more modest, homes to humble collections of stars dancing gently through darkness. This spectrum of halo sizes builds a cosmic hierarchy, small galaxies nestled within the gravitational embrace of larger ones, much like the branches of an ancient tree reaching towards the sky. As these galactic structures take form, the influence of dark matter grows ever more apparent. Like an unseen librarian, it catalogues the places where matter may gather, ensuring a careful balance. Without this silent force, the universe's grand design would unravel. The gas would spread thin, unable to clump and cool, leaving a universe bereft of galaxies, a silent sea of emptiness. We can pause for a moment to appreciate this profound balance. Though light from distant galaxies paints the night with brilliance, it is the dark matter, the silent hidden web that shapes the universe's unseen skeleton. This invisible scaffolding is intertwined with visible matter, yet it itself remains elusive, never captured by our instruments, known only through its gentle influence on galaxies' motions. When we gaze at a galaxy twirling softly against the night sky, we are glimpsing a structure balanced delicately on this underlying network. The stars we see trace spirals and clusters, their paths governed by the gravity of dark matter, halo cradling them close. Scientists measure these subtle motions by tracking how stars and gas clouds orbit around galaxy centers. They found long ago that galaxies don't quite move as expected if only their visible matter was there. There must be more, the dark matter that tugs gently, holding stars in their course. This cosmic truth speaks of a universe much larger than the one we see, a universe where spirit and substance softly intertwine, where invisible hands caress the visible forms with quiet care. Imagine dark matter not as silent absence, but as a gentle presence, an unseen guardian maintaining the cosmic order. Galaxies themselves are not static. They grow, merge, and evolve through time. Dark matter halos too, pull together in a gentle embrace, merging like whispers joining to form a chorus. These cosmic mergers lead galaxies to collide and combine, creating new structures, sometimes magnificent spiral giants, other times dense elliptical clouds of stars. Each union echoes the gravitational song sung by dark matter, softly shaping the past into the present. As they merge, gas is compressed, new stars ignite, and sometimes enormous black holes at galactic centers awaken, gobbling matter with quiet hunger. Yet even in these violent moments, the dance is controlled by the dark matter halo's embrace, a slow process unfolding over eons, calming the chaos into new order. And as the galaxies shift, dark matter continues its role as the invisible architect, subtly molding their destiny with patience beyond human measure. Beyond individual galaxies, dark matter weaves even grander structures, the cosmic web. Vast filaments of dark matter stretch ensnaring countless galaxies, threading through the dark void like shimmering threads of light, invisible but unyielding. These filaments connect clusters of galaxies, binding vast regions, directing matter's flow across unimaginable distances. They are the highways of the cosmos, carrying gas and galaxies along gentle currents, expanding slowly as space itself stretches. You might picture this cosmic web as an ancient lace, delicately patterned and endless. Where these filaments intersect, gravitational forces deepen, gathering more galaxies into clusters, shining softly through the darkness. These clusters mark the grandest gatherings of matter, the cities of the cosmos, resting on foundations laid in darkness. The gravitational pull within these clusters is so immense that it warps space itself, bending the light of distant objects, a phenomenon called gravitational lensing. This modern discovery allows us to map dark matter's elusive distribution, brushing our hands lightly over the invisible web. With every observation, the portrait of dark matter's grip on the cosmic dance grows clearer, yet still mysteriously gentle. In this way, dark matter's influence extends from the smallest galactic neighborhoods to the great cosmic stretches, shaping how galaxies form, grow, and assemble into vast structures. It is a quiet sculptor, unseen but deeply felt, patiently guiding the flow of matter through deep time and space. Our understanding of dark matter's role is continually deepened by human curiosity and innovation, yet it remains as elusive as a shadow in twilight. We know it exists because of gravity's persistent tug, the way galaxies spin and cluster beyond what visible matter could dictate. We know it must be the key to forming the universe's grand architecture. And we know in the heart of this mystery lies a deep, slow truth about how the cosmos grew into the wondrous expanse we behold. Tonight, as your breathing slows and your mind drifts gently into dreams, Imagine the dark matter web. Picture yourself floating softly through the silent dark, tracing the invisible threads that connect stars and galaxies. Sense the slow pulse of gravity, a lullaby hummed across billions of years, nudging tiny particles into magnificent forms. Let the thought of this unseen influence quiet your mind. Just as dark matter holds galaxies in tender embrace, so too does patience hold your own thoughts, weaving calmness through the fabric of your being. In this moment, suspended between waking and dreaming, you are part of the same cosmic dance, held gently by the invisible forces that shape all things. The night sky above you is vast and quiet, yet beneath its surface lies a subtler story, one of silent gravity and hidden matter, of slow creation and unseen harmony. It tells us that, even in darkness, there is form, structure, and purpose. There is a graceful balance, a cosmic order that unfolds patiently, like petals opening slowly to reveal the starry blooms inside. Rest now with these thoughts, soft as a whisper, deep as the night itself. Let the universe's quiet watchfulness soothe your soul, as gentle and unhurried as the galaxies that grow in the tender arms of dark matter. Drift deeper now, carried on the serene currents of gravity's quiet pull, resting in the knowing calm of the vast, unseen cosmos. And as your mind floats, carried along by invisible waves of time and space, feel yourself merging with the cosmic web, a single strand, a quiet presence woven into the infinite tapestry of night. This is the slow and steady dance of the universe, where unseen forces guide and hold, where galaxies form and grow, and where you too can find rest and belonging in the great dark embrace of space. Breathe softly, peacefully, and let the gentle gravity of sleep draw you fully into its tender fold. Here, beneath the endless sky, carried by the quiet power of dark matter's invisible hand, you are safe, you are still, and you are home. As you settle more deeply into the calm of this quiet night, let us continue our gentle journey through the subtle, unseen qualities of our universe. We have already wandered through the nature of matter as we know it, ordinary and familiar, and traced some of the trails that hint at unseen forces whispering through the cosmos. Now, as the darkness deepens beyond our quiet room, we draw our attention to the quiet companions of light and structure, dark matter and ordinary matter. Imagine, if you will, the vast vault of the sky, spangled with pinpricks of starlight, each a distant sun amid the endless night. These stars, these shining orbs of fire and gas, are woven from ordinary matter. It is the substance born from the first moments of creation, made of atoms, tiny clusters of protons, neutrons, and electrons. These are the bricks and mortar of everything we can touch, taste, see, or feel. This ordinary matter shapes the planets beneath our feet, flows in the rivers, fills the air with breath, and builds the bones and hearts of life itself. But alongside this familiar matter, there exists something more elusive. Scientists call it dark matter, but it is not dark in the way that the absence of light feels dark in a room. No, it is more a shadow hidden in the fabric of reality, a presence felt by its gravity, yet invisible to every lantern of observation or glance, through even the most powerful telescopes. While ordinary matter shines, absorbs, reflects, and refracts light, engaging in a delicate dance with photons, dark matter neither emits nor scatters light. It is effectively silent in the electromagnetic symphony. Let's pause together in this thought, allowing it to settle like a soft mist across a tranquil lake. Ordinary matter listens to light's tune, but dark matter lies beyond this melody, unseen and unheard, yet exerting a weighty influence on the cosmic stage. This invisible hand tugs upon galaxies, anchoring their graceful spirals as they spin through the infinite dark. So, what is there to tell about the gentle distinctions between these two cosmic substances? First, let us consider composition. Ordinary matter, the material of everyday life and starry heavens, is composed of atoms, complex structures where charged particles harmonize in precise balance, positively charged protons, neutral neutrons, and negatively charged electrons. These atoms form molecules, creating everything from water to the intricate proteins in a leaf or the solid mineral bones embedded within a living creature. This matter participates fully in electromagnetic interactions, known to you as light, heat, magnetism, and electricity. The atoms can absorb and release photons, enabling the stars to shine, the air to glow with auroras, and the kaleidoscope of colors that paint our sunsets. Dark matter, however, is a different story altogether. The particles that compose dark matter have no known electric charge. They do not clump into atoms or molecules. Instead, they drift in diffuse halos around and within galaxies, invisible yet profoundly present. Scientists theorize that dark matter is made from exotic particles, unlike the building blocks of ordinary matter, which interact only weakly, if at all, with light and normal matter, except through the gentle pull of gravity. Imagine shadow-like particles slipping quietly past one another, rarely colliding or gathering, yet collectively possessing enough mass to shape the motion of stars and galaxies. Now, if ordinary matter forms the radiant bodies of planets, stars, and clouds, dark matter is more like an unseen scaffold or matrix beneath the visible universe. This cosmic web, woven from dark matter filaments, directs the large-scale structure of the cosmos. Galaxies are not islands drifting alone, but are tied by thin, ethereal threads of dark matter stretching across unfathomable distances. In this way, dark matter acts as the cosmic architect's invisible hand, determining where ordinary matter can collect, collapse, and ignite into shining clusters of stars. On our journey, we can also feel the pulse of time coupled with these materials. Atomic matter, by its very nature, participates in the complex interplay of forces, including the strong and electromagnetic forces. These interactions cause ordinary matter to have temperature, solidity, and the capacity for chemical reactions, a lively dance of change and motion. Dark matter particles, however, do not partake in these dances. They do not warm under the sun's rays, nor do they cool in shaded places. They remain cloaked in silence, their movements governed chiefly by gravity's steady pull. This leaves them cold and quiet, forming vast halos and frameworks, but never heating or cooling, glowing or freezing. In quieter moments, when your mind drifts gently, it is worth considering the abundance of each. Though ordinary matter fills our daily experience, it comprises only a small fraction of the total material content of the universe. Measurements of the cosmic microwave background, the faint afterglow of the Big Bang, along with the motions of galaxies and clusters, have revealed that ordinary matter accounts for less than 1/6 of the universe's total matter. The rest, more than 5 times as much, is dark matter. Let this fact wash over you softly, like a gentle evening breeze, nudging your awareness toward the vast unknown. The universe we inhabit is mostly composed of something beyond our direct senses, an invisible yet powerful presence that indicates how much there remains to be discovered and understood. It is a humbling and beautiful truth that the cosmic stage is largely set with materials outside our immediate grasp. As we explore further, imagine tracing the paths that light and matter take in a galaxy. Stars orbit around the galaxy's center, their motions mapping out the gravitational landscape. When we measure these stars' speeds, we find something curious. They move faster than expected, if only the visible matter's gravity pulled on them. Something else, dark matter, must be present, exerting an unseen gravitational pull to hold the stars in their swift orbits. Even in the voids between galaxies, dark matter lingers, an omnipresent sea in which the islands of luminous matter float. The gravitational presence of dark matter affects not only individual galaxies, but also entire clusters, shaping their mergers and dances across cosmic epochs. Through the gentle force of gravity, dark matter binds together the visible cosmos in a subtle, continuous embrace. Looking closer still within our own galaxy, the Milky Way, dark matter forms an expansive halo. This halo extends far beyond the bright disk where billions of stars reside. It is diffuse but massive, enveloping the galaxy in a protective cloak. Ordinary matter, by contrast, clumps with intimacy. Stars gather in clusters, and nebulae swirl with life, gas, and dust. Dark matter, on the other hand, is formless, spread thinly and ghost-like. Pause now and breathe quietly with this image, the familiar night sky above, lit by stars, planets, and the soft glow of our home galaxy, framed within a halo of invisible dark matter. The known and unknown resting side by side, reminding us that what we see is but a part of the whole. We may also consider how ordinary and dark matter respond differently to the universe's expansion. Ordinary matter clusters together under gravity, but also participates in the dynamic flow of energy and radiation. Dark matter, conversely, is thought to be cold, moving slowly compared to the speed of light, allowing it to form the gravitational skeleton upon which ordinary matter assembles. Its lack of electromagnetic interaction means it does not slow down or heat up through collisions, allowing it to retain the primordial patterns that seeded galaxy formation. As you imagine these expansive concepts, picture the universe's early moments, when the cosmos was a hot, dense soup of particles. Ordinary matter existed then as protons, neutrons, and electrons, slowly combining into the first atoms as the universe cooled. Dark matter, meanwhile, existed as yet unknown particles, indifferent to light and radiation's dance, setting the stage quietly in the shadows. The differences between these two substances extend beyond composition and interaction. They shape our cosmic history and future. Ordinary matter is subject to the full palette of physics. Electromagnetic, nuclear, and gravitational forces intertwine to create complexity, structure, and life. Dark matter, by being immune to light and most forces but bound by gravity, acts as the unseen hand that guides structure formation, yet remains impervious to the thermal and chemical processes that ordinary matter experiences. Now, perhaps you imagine peering through a great telescope, observing the heavens in wavelengths beyond visible light, in the X-ray or infrared or radio waves. Even here, through these many eyes, dark matter remains a silent partner, detectable only through its gravitational effects. Ordinary matter can be seen glowing hot, heating interstellar gas, or clumping into stars and planets. Dark matter's presence is inferred by the motion it imposes upon these luminous structures. Together, ordinary and dark matter create a universe of interplay, balance, and mystery. They are two fundamental ingredients in the cosmic recipe, each vital yet distinct. As your body begins to soften into rest, allow these images to settle gently into your mind, a universe composed mostly of mystery, where light dances along an invisible framework. Ordinary matter, the familiar, shines and changes, while dark matter silently holds the cosmos together with steadfast grace. Imagine now the quiet night sky, its stars glimpse through the dark matter's unseen scaffold. The ancient light is a whisper of the past, travelling through space and time, passing silently through clouds of dark matter that neither slow nor absorb it. The cosmos is vast, deep, and filled with secrets yet to be unravelled. Your breath, slow and even, echoes the rhythm of this grand cosmic balance, the elegant difference between the matter we know and the matter we do not fully understand. Let your thoughts drift freely among these cosmic realms, carried softly on the breeze of night. Feel the peaceful weight of ordinary matter giving shape to the world you know, while dark matter gently cradles the universe within its invisible embrace. And as the night carries you further into sleep, remember this quietly profound truth that we live in a universe where the visible and invisible coexist, where light and shadow are woven together into the fabric of time, and where the dance of ordinary and dark matter continues silently above us, whispering the secrets of existence across the endless night. As we settle deeper into our quiet exploration of the unseen fabric of the cosmos, imagine once more a sky cloaked in velvet night, speckled with stars whose light has travelled millions, even billions of years to reach us. Beneath this vast expanse, the universe whispers its riddles, among them the mysterious substance known as dark matter. As we continue on this gentle journey through the ideas and particles proposed to explain it, let your thoughts float slowly like a feather drifting through the still air of an ancient library. We have come a long way in our understanding, how the galaxies swing and swirl, how stars move in their quiet orbits, revealing through their motion the presence of something more. This invisible something, a binding essence, perceived only through its gravitational pull, is what we call dark matter. It does not shine with a star's fire, nor does it reflect the soft light of distant nebulae. Instead, it remains elusive, silent, hidden, yet indispensable. In our previous talks, we spoke of the evidence in the cosmic dance, how galaxies seem tethered not just by visible stars and gas, but by an unseen mass. We trace the echoes of the early universe, the cosmic microwave background, and how the large-scale structures woven across space bear the fingerprints of dark matter. Today, we delve deeper into the concepts and particles that scientists have imagined, conjured, and pursued in their quest to bring this mystery into the light of understanding. Imagine a world beneath the glow of dim candlelight, where scholars long ago pulled dusty scrolls and fragile manuscripts from towering shelves. Each page turned reveals fragments of cosmic lore passed down through generations of thinkers, those who, with patience and wonder, sought to decipher the unseen forces shaping existence. In this serene atmosphere, let us consider the ideas conceived to explain dark matter, a journey marked by both hope and humility. The earliest and perhaps one of the simplest candidates proposed was that dark matter might be made up of ordinary particles, just like the atoms composing you and me, but in forms that are hard to detect, objects too small, cold, or faint. These came to be known affectionately as machos, or massive compact halo objects. Picture, if you will, dim, lonely remnants of ancient stars, black holes, neutron stars, brown dwarfs, floating silently in the halos surrounding galaxies like celestial ghosts. They are real, these objects, detected in the depths of the sky, yet their numbers seem insufficient to account for all the dark matter. It is a gentle reminder that sometimes familiar things, even when cloaked in mystery, may not tell the entire story. From these known possibilities, the path widens towards more exotic and subtle realms of particles, cosmic phantoms with names that echo in the corridors of theoretical physics. The story of dark matter is, in many ways, a story of particles beyond the reach of our senses and instruments, elusive inhabitants of a hidden sector of reality. One leading character in this cosmic tale is the WIMP, the weakly interacting massive particle. Imagine one such particle drifting through space, almost imperceptibly. It interacts so faintly with ordinary matter that it can pass through entire planets with barely a whisper of a touch. Yet, in the vastness of the cosmos, countless WIMPs together influence the gravitational scenery. Originating from theories that extend the familiar standard model of particle physics, WIMPs have long been beloved candidates because they offer an elegant solution, that is, the precise amount of WIMPs left over from the early universe's fiery beginnings matches the amount of dark matter we observe today. Like whispers from the dawn of time, their abundance feels just right. But despite determined searches deep underground, in detectors shielded from the noise of everyday particles, WIMPs remain hidden, as elusive as shadows in a moonlit forest. Alongside the WIMPs, another intriguing possibility shines softly in the realm of thought, the action. It is named after a common household detergent, a whimsical choice by a clever physicist, but do not let this distract you from the action's quiet significance. Born from the attempt to solve a deep puzzle about the behavior of the strong nuclear force within atomic nuclei, axions are incredibly light particles with such feeble interactions that astronomers imagine them filling the universe like a gentle mist. Envision the axion fields permeating space, their presence felt not through light or sound, but as a subtle background hum beneath the stars, a cosmic whisper woven into the fabric of reality itself. Experiments, vast and delicate, seek to coax these whispers into a detectable murmur, tuning resonant cavities in deep shielded labs, waiting for the faintest hint. Beneath these familiar shadows, theoretical physicists also explore realms of greater complexity, conjuring new symmetries and dimensions. The notion of supersymmetry, for instance, suggests a hidden partnership between the known particles and their heavier, shadowy counterparts. In this elegant dance, each particle we know would have a super partner, a sibling particle with different spin, quietly existing at scales just beyond our current reach. Among these superpartners is the neutralino, a promising composite that could serve as dark matter. If the universe is indeed supersymmetric at its heart, then galaxies might be cradled gently by clouds of neutralinos, the quiet guardians of cosmic structure. Beyond even supersymmetry, theories invoke hidden sectors of particles, realms where forces and matter interact with their own subtle laws, separated from ours by a veil of feeble interactions. Particles in these sectors might communicate with our world only through gravity or through rarely flickering portals. Could dark matter consist of such dark photons, or perhaps some entirely new family of particles waiting silently beyond the veil? The elegance of these ideas paints a cosmos more layered and intricate than once imagined, as if the universe is a grand library of realities, pages yet unread. Let us walk through these ideas slowly, as if passing softly by ancient manuscripts on wooden shelves. The WIMP hypothesis rose out of a beautiful coincidence in the early universe. When the cosmos was young, a hot, dense sea of particles danced in equilibrium. As it cooled, certain particles ceased interactions and became a fixed presence, a relic abundance. The weak interactions that govern WIMPs allowed just the right freezing out, leading to the amount of dark matter inferred from astronomical observations. It is a story blending the small with the vast, a delicate balance woven into the fabric of cosmic history. Yet, the quest to find WIMPs has been challenging. Detectors buried deep underground use layers of shielding to block cosmic rays, waiting for the rare, almost imperceptible collisions between WIMPs and ordinary atoms. Each possible event is treasured, recorded, and analyzed, like listening carefully for a single whispered word in a vast, empty hall. But as of now, the silence remains. This silence has inspired physicists to widen their gaze, to consider lighter particles beyond the reach of traditional WIMP detection. Axions arise naturally as solutions to another enigmatic question: why the strong nuclear force respects certain symmetries when it need not. The axion field would pervade all space, and in its slow oscillations it could make up the dark matter that holds galaxies in their graceful embrace. Axion searches use resonant cavities cooled to near absolute zero, where electromagnetic fields flicker gently, awaiting the faint conversion of axions into photons. Throughout this cosmic night, you can picture these particles, eternally mysterious and subtle as mist-like presences underlying the arcing motions of galaxies. They form halos beyond the luminous stars, invisible scaffolding that shapes the visible universe. Other candidates exist too, filling the pages of theoretical physics with varied whispers. Sterile neutrinos, for instance, imagined kin to the known neutrinos, but without normal weak interactions, could drift unseen through our bodies and planets alike. Their faint decay over cosmic time could leave signatures in X-ray light, subtle glowings that distant telescopes continue to search for. More speculative still, the idea of dark sectors introduces new mirror worlds, where particles interact strongly with each other but barely with us, coupled only weakly through portals such as kinetic mixing. These hidden sectors might harbor complex dark matter behavior, perhaps even forming dark atoms and dark molecules, entire invisible chemistry ruling secluded realms within our reality. At the grandest scale, these ideas entwine with the story of cosmic structure. The distribution and clustering of dark matter influence galaxy formation, gas clouds collapse, and the cosmic web that stretches across billions of light years. Through careful mapping of these structures, astronomers glimpse constraints on what form dark matter might take, how warm or cold it must be, how it should behave at small scales, all subtle clues whispered through the grand cosmic tapestry. This journey to understand dark matter is a story still unfolding, a soft mystery that invites the patient and the imaginative alike. It blends the smallest scales of particle physics with the vast scales of galaxies and beyond, a cosmic symphony played quietly in the background of our own lives. As you drift gradually towards rest, imagine these invisible particles gently passing through, unseen and unfelt, yet essential. Picture the interplay between the known and the unknown, the seen and the unseen, weaving the universe's grand design without fanfare, with quiet grace. In these moments of stillness, consider the elegance of nature's secrets, how the universe, in its infinite complexity, offers puzzles both profound and subtle. The particles proposed as dark matter are more than theories. They are invitations to wonder, to exploration, to humbly observe the unseen realities that cradle the stars. So let your breathing slow, your mind soften as these quiet cosmic stories lull you onwards. Theories rise and fall, searches continue, and the night sky keeps its treasures locked in silence. Yet, beneath the calm, the universe whispers still, carrying the promise of discovery and the gentle rhythm of timeless mystery. Allow yourself to drift alongside this cosmic tale, floating like a leaf on a gentle stream of knowledge, through the quiet corridors of thought, a place where curiosity and calm intertwine. Here, the mysteries of dark matter in their slow unfolding become a lullaby, a soft murmur beneath the vast serene canopy of stars. And as you journey deeper into sleep, held by this cosmic embrace, the universe continues its dance, particles and theories entwined in the endless quiet, weaving the invisible threads that bind galaxies, stars, and dreams. As the soft amber glow of a solitary lamp hums gently in the quiet room, we continue our drifting journey deeper into the silent cosmos, tracing the delicate threads of a mystery that has quietly tugged at the minds of scientists for nearly a century. We have by now already wandered through time and theory, met the whispers of particles that evade our grasp, and felt the shadowy contours of what we call dark matter brush faintly against the edges of understanding. In this, the sixth part of our shared voyage, let us settle once more into the gentle current of thought and explore how today's seekers at the frontiers of knowledge gently pluck at the veil, and what soft promises lie ahead in the endless night. Imagine a library, ancient and vast, where volumes upon volumes are filled not with words, but with the subtle sway of stars, the faint tremors of cosmic phenomena, and the delicate patterns of particle interactions. This library is tended by curious minds, astronomers, physicists, engineers, who work in concert, yet with wonder and patience, as if coaxing a secret from a long-lost language. Here, in this tranquil retreat of the universe's hidden stories, researchers are weaving together clues from the cosmos itself, glimpsing patterns that might one day illuminate the true nature of the dark matter which clouds our sight. One of the quietest yet most profound whispers comes to us from observatories perched in remote, high places where the air is pure and the light faint. These aren't luminous beacons, but rather delicate instruments that listen rather than shout. Subtle arrays of sensors tuned to the quiet background radiation of the universe, or vast underground chambers nestled far beneath the Earth's protective crust, where scientists hope to detect the faintest murmur of particles that might be part of the dark matter sea. These detectors rest in silence, some submerged in liquid noble gases, cooled near absolute zero to quiet their throbbing electronic hearts. There, encased in layers of shielding, they wait patiently for a rare event. A dark matter particle, if it exists in the form we suspect, might reach out momentarily, whispering a soft tap, an interaction so light that it might go unnoticed by other means. The apparent stillness of these experiments is deceptive. It hides the hopeful pulse of possibility, a quiet anticipation akin to a lone listener hearing the faint rustle of leaves in a vast forest. Researchers have built devices such as the cryogenic bolometers, time projection chambers, and scintillating crystals, each finely tuned to catch these elusive ripples. And yet, despite decades of listening and counting, the definitive echo of dark matter has not yet been found. This absence is not discouragement, but a gentle pivot, a quiet encouragement to look deeper, adjust the tuning, expand the listening to new frequencies, explore new paths. Parallel to this underground listening, the universe itself provides a symphony for those who care to hear. Telescopes, both on Earth and in orbit, look deep into the ancient light bathing us from all directions. Some focus on the grand ballet of galaxies, noting how they swirl and stretch, almost as if moved by an invisible hand. Others gaze at distant phenomena, gravitational lensing, where the fabric of space-time itself bends the path of light, revealing the subtle imprints dark matter leaves behind. Through careful study of these distortions, scientists map the unseen web that dark matter weaves across cosmic scales, the scaffold upon which visible matter clings. Yet the discoveries of recent years have shown us the cosmos can be as mysterious as ever, drawing us into more subtle questions. In some regions, the distribution of dark matter appears to be less dense than anticipated, while in others, tiny clumps suggest particles might interact or cluster differently. These delicate inconsistencies ripple through theoretical frameworks, inviting alternative ideas and nuanced models. Perhaps dark matter is not a single kind of particle, but a more complex family, like a shadowy population with varying traits. This thought stirs scientists' imaginations like the flickering flame of a candle in a darkened room, prompting new experiments and refined calculations. In laboratories bathed in the glow of quiet computer screens, theoretical physicists compose equations that might explain these nuances. Some propose that dark matter candidates are part of a wider sector of particles that interact only weakly with regular matter, or that they might be composed of ultralight fields, resembling invisible waves gently permeating space. Others speculate on the possibility of self-interacting dark matter, particles that subtly influence each other in a cosmic dance, reshaping the structure and evolution of galaxies. These theories offer not just new avenues of research, but also a glimpse into a richer cosmos, where what is unseen is as intricate as what is visible. The experimentalist's quest ripples outward too, embracing novel methods. Particle accelerators, the grand instruments that once revealed the Higgs boson, now reach for new frontiers. Though dark matter particles may be elusive, scientists hope to produce them fleetingly in high-energy collisions. The Large Hadron Collider and prospective future colliders may open windows into realms where dark matter reveals itself, even if only momentarily, through subtle transformations and decay signatures. This approach is akin to shining a focused beam of light into an opaque mist, seeking the faintest glimmer that betrays presence. Beyond Earthbound experiments, sensors on spacecraft venture into the silent reaches. They carry instruments to measure cosmic radiation, antimatter, and particles streaming through the solar system. Sometimes these instruments detect unexpected excesses or anomalies, gentle hints that might one day shed light on dark matter's character. The careful celestial measurements collect quietly, day by day, their data forming a tapestry woven with patience and precision. As the night deepens, so does the profound patience of these researchers. It is a subtle dance, requiring the steady rhythm of hope and inquiry. When one path closes, an experiment yields no detections, a model proves insufficient, they return to the beginning with quiet humility, adjusting, refining, and trying anew. There is a kind of beauty in this persistence, a solemn reverence for the truth residing beyond reach, but not beyond desire. The future of dark matter science remains uncharted, like the vast seas at the edge of an ancient map marked with the simple words, "Here be mysteries." Yet the compass of knowledge is steadily being tuned. Upcoming experiments will increase in sensitivity, expanding their reach to particle properties so slight we have not yet imagined their full effect. Technologies will evolve, borrowing from advances in quantum mechanics and nanotechnology, enabling detectors to discern interactions with unprecedented delicacy. Collaboration spanning continents and disciplines will grow, blending expertise and perspectives, as one might blend colors to paint a more accurate portrait of the cosmos. As sleep gently settles over us, let us consider too the possibility that dark matter is but one part of a broader cosmic puzzle. The universe might harbor other enigmas, dark energy, the accelerated expansion's quiet pull, or exotic particles yet unnamed that form a subtle interplay. Scientists ponder how these pieces fit together, inviting concepts that reshape our view of space, time, and the very fabric of reality. Perhaps in the unfolding future we will glimpse that dark matter is not merely a shadow cast over galaxies, but a window into a deeper cosmic substratum, a realm where new physics patiently waits to tell its story. In these quiet hours, when the mind softens and the body begins its descent into rest, we join a timeless chain, curious beings gazing upward and inward, seeking light amid darkness. The ongoing research into dark matter is like the turning of pages in an ancient manuscript whose ink is made not of words but of stars and particles, whose narrative is written in equations and tentative discoveries. It is a narrative that honors patience, subtlety, and the inexhaustible wonder that stirs the human heart. So as you lie still, surrendering to the gentle pull of slumber, picture the unseen particles weaving their silent dance, invisible but present, shaping the universe's vast architecture. Imagine the dim glow of underground halls where scientists wait in hushed anticipation, and the steady gaze of telescopes watching galaxies spiral in the distance. Feel the quiet hum of knowledge growing, the delicate unfolding of revelation, patiently paced, unfolding like a flower at dawn. Slowly, surely, and with infinite grace. Know that in this sleeping moment the universe itself is awake, awake in its vastness, awake in its mysteries, softly inviting us to dream alongside it, to drift along the quiet currents of discovery. And when morning light filters gently through your window, perhaps you will carry with you a fragile, shimmering thread of wonder, a whisper from the domain of dark matter, twining itself gently with your thoughts, lifting you in quiet awe toward the infinite night. As we drift to the close of our cosmic waltz with dark matter, let's take a moment to marvel at its quiet dance, a ballet of unseen forces that shape our universe. Like a comet tail fading into the hush of space, these mysteries beckon us further into the cosmos. Until we meet again, dear dreamers, may your thoughts twirl with wonder, eager for more Dreamtime tales. If sleep has already taken you, may your dreams stay gentle. If you're still awake, feel free to let your mind wander back over the quiet marvels we've uncovered. When morning comes, you can always return for another Dreamtime tale, and I'd love to know which mysteries you'd like to explore next. Sleep now among the gentle stars. Until then, thank you for sharing this calm corner of the cosmos with me. Rest well, breathe deep, and I'll meet you again beneath the stars. Good night.